All right, this is our second video for the Test 1 review. So here we're solving this compound inequality. You got negative 4x minus 2 is less than negative 6, or negative 4x minus 2 is greater than 6. So basically we solve each of these individually, and when we get our solution we put them together with an OR. So I'm going to do kind of like what I did on the last problem. I've got the two problems written. Again, there's an OR in between. And in both cases, I'm gonna, I'm gonna want to add 2 to both sides. And when we do that, we get, over here, negative 4x is less than negative 4. Over here, we get negative 4x is greater than 8. Again, you could do this one and then do this one separately, but either way, you should get the same answers I'm getting here. Notice I need to divide by negative 4 here, and so I'm going to have to reverse the symbol there. Similarly, the same thing will happen here because I'm dividing by negative 4. And so this will be x is greater than 1. And over here, we're going to have x is less than negative 2. And again, we want to put the word OR in between. Now, notice the numbers greater than 1 are bigger than the numbers less than negative 2. We always want to put our we want to go from left to right, smaller numbers to bigger numbers. So our set includes the numbers less than negative 2 or the numbers that are greater than 1. So let's see, we need x less than negative 2 or x is greater than 1. So this is going to be A here. All right, let's move on to the next page. All right, so on number 12, we're solving an absolute value equation. And with an absolute value equation, there's two cases. Notice what's in here. When we take the absolute value of it, we get 4. Well, there's only two numbers in which you take the absolute value and you get 4. Either 4x minus 3 must be negative 4, or 4x minus 3 must be positive 4, because we know the absolute value of 4 is 4, and we know the absolute value of negative 4 is 4. So again, what's inside the absolute value, in order for this absolute value to equal 4, the 4x minus 3 must either be negative 4 or 4. So now when we solve these equations, we're going to add 3 to both sides. You get 4x equals negative 1 here. Here you get 4x equals 7. I'm going to divide both sides by 4, and I get x is negative 1/4 here. And here I get x is 7/4. And we'll put those together. Well, actually, we'll write them as, this is what we call a solution set. And in this case, there's two answers in our solution set, negative 1/4 and 7/4. All right, let's move on to number 13. So this is an absolute value where you have greater than a number. This is what I call the OR case. Now, what I'm about to tell you hopefully will help you make a little sense out of our next step. I should say it this way. In the OR case, in this case, where you have greater than or equal with absolute value, you're going to end up with two inequalities. 8x minus 3 is less than negative 6. So notice I switched the symbol and I changed the sign. Or notice this case looks just like the original. 8x minus 3 is greater than 6. So how do we make sense out of that? Remember, absolute value is distance from 0. So the distance from this number to 0 is greater than 6. So that means 8x minus 3 is either out here, which means 8x minus 3 is greater than 6, or this number 8x minus 3, or I guess it's 8y minus 3, is less than negative 6. So it's out here. And so again, the first step going from this absolute value inequality is to write this OR equation here. All right, so we're going to want to add 3 to both sides. You get 8x is less than negative 3 here. Here you get 8x is greater than 9. In both cases, we're going to divide by 8 next. So we'll get negative 3/8 here. Dividing by 8 here, you get 9/8. And so our answers are going to, and notice there's an or in between. Now notice x less than negative 3/8, that's the smaller values, and the numbers x that are greater than 9/8, those would be the larger. So we do want this on the left. So it'll be, I keep using x, I'm sorry, this should be a y. These are all y's. So we have y is less than negative 3/8, or y is greater than 9/8. And so that would be D. All right, let's look at number 14. So here we're solving, let me push this up a little further. Okay, so here we're solving an inequality, an absolute value inequality where you have a less than or equal. This is what I call the and case or the between case, because basically what we're saying is the distance from this number 7x minus 7 to 0 is less than or equal to 8. Well, aren't those numbers in here? These are all the numbers whose value is, or whose distance from 0 is less than or equal to 8. That means 7x minus 7 is in here. So in this case, this is how we translate this inequality. The first step would be to write 7x minus 7 is between negative 8 and positive 8. So again, I call this the between case. So if you have a greater than like we did before, we end up writing an or statement. The right side looks just like what's inside here. The left side, the symbol reverses and the sign changes. For the and case, whatever's in here goes between this number and its negative. That's how we always handle that. So hopefully you understand what I was saying here, but the most important thing is that you can start by writing it this way. And then we solved one of these earlier. We need to get x in the middle by itself. So we're going to want to add 7 to both sides. Actually, to all 3 parts. We'll get negative 1 is less than or equal to 7x is less than or equal to 15. And it doesn't look like our numbers are going to be all that nice. We're going to have to divide by 7 on each part. We get 1/7, negative 1/7 is less than or equal to x is less than or equal to 15/7. And that goes right here. So negative 1/7 and they're 15/7. So that was option B. All right, number 15. Determine whether the ordered pair is a solution to the given linear equation. Well, if you plug in 1 for x and 3 for y, we want to see if it makes that a true statement. That's what I did here. That's 4 minus 3 is 1, which is certainly true. And so yes, that is a solution to that equation, that linear equation. In other words, if we graph this linear equation, that point would be on the line. In fact, there's infinitely many solutions. This is just one. Let's move on to number 16. So here we're just plugging values into this function. We have an equation for it. So what I always encourage students to do is make a skeleton and then plug in your input. And basically all we did is wherever there was an x, now we see parentheses, so we're just going to put zeros in here. And so now notice everything zeroes out. This is 0 minus 0 or 0, so f of 0 is 0. Now if we plug in negative 1, we'll do that over here. So again, we're just replacing all our x's with -1. And now we're just simplifying using the order of operations. So you're going to want to square first. -1 times -1 is 1 times 2, which is 2. And this will be plus 2, and so we get 4. And then we have one more. We need to find f of 2. Let me stretch this out just a little more. So if we plug in 2, remember we're going to square first. You don't want to multiply here first. So 2 squared is 4. 4 times 2 is 8. This will be 8 minus 4, which is 4. So that's number 16. All right, let's move on to the next problem. All right, so here we're going to graph this linear function. Notice it's in slope-intercept form. You could remember f of x is just another name for y. It's what we call function notation, which emphasizes the fact that the value of the function is dependent on what you choose for x. So in this case, our slope is 1/4. Remember, that's rise over run. And the y-intercept is this value here. Remember, the y-intercept is a point. It's the point 0, 7. And so we're going to start at 0, 7. We're going to rise 1. And we're going to run 4. 1, 2, 3, 4. Puts us right here. And you can draw the line. You could go up 1 and write 4 again if you wanted another point, or you could go down 1, left 4, down 1, left 4. That would also work. All right, let's move on to number 18. Determine whether the following is the graph of a function. Well, when you draw vertical lines through here, we call this the vertical line test. No matter where you do that, you can only go through one point. And so, yes, this is a function. If you had something like this, notice that would not be a function because it would not pass the vertical line test. All right, let's move on to 19. So we got a lot of work to do here. So it says, use the graph of the function to find the following, f of -1. Well, there's two ways to do this. We could find the point on our graph that has an x value of -1 and find the corresponding y value. Well, x is -1 right here. Notice this is the point that has an x value of -1, and also the y value is -1. And so f of -1 is -1. The other way to figure this is to think of it this way. When x is -1, what's the height of the graph? Well, it's down 1. So f of -1 is -1. What's our domain? Well, remember, with domain, we go from left to right on the graph, to the leftmost to the rightmost point, and we look at x values. Well, since there's no leftmost point, because this continues to go left forever and continues to go right forever, there's no holes or gaps in between, so it's going to be all real numbers. Now, remember, in interval notation, it would look like this. You should be comfortable with either. We also use this symbol here. Find all x values such that f of x equals -4. Now notice this time they gave you an output or a y value. So we're looking for the point on the graph that has a y value of -4. Well, here's where y is -4. That would be the point that has a y value of -4. The corresponding x value is -2. And so x would be -2. Now there's another way to do this. If I'm looking for an output of -4, I want to know where the graph has a height of -4. So here's where the height is -4, or the graph is down 4. It occurs right at that point where x is -2. What's the range? Remember, with range, now we're looking at y values. We go from the lowest point to the highest point. Well, again, there is no lowest or highest point, so it's going to be all real numbers. All right, let's go ahead and do one more problem. Number 20. This one's got a lot to it. Okay, so let's see. We have to find f of 2. So when x is 2, what's the height of the graph? Well, we're up 2. What's the domain? Notice it goes forever left. No gaps or anything. Goes forever right. So the domain is all real numbers. Again, in interval notation, that would be negative infinity to infinity. For what x values is f of x equal to 1? So again, notice here we have an output or a y value. And so we're looking for the output or the x value for which we have an output of 1. Basically, I want to know where the height of the graph is 1. That happens here and here. Notice each of those points have a y value of 1. The x values are 3 and 5. So x equals 3 and 5. Notice f of, 3 is 1. And f of 5 is 1. So those are the two x values that have an output of 1. Finally, what's the range? Well, let's see. We do have a lowest point, and the y value at our lowest point is 0. Now notice there is no highest point, and so our range, now keep in mind that point is on the graph, so 0 is a y value for one of our points. And so basically it's going to be y is greater or equal to 0. And usually we write that in interval notation. It would look like this. But they're just asking for set notation, so that'll be right here. All right, so that's going to be it for 11 through 20. We'll stop right here.